Today with constructing functions, let me get rid of this here. All right, we're going to be talking again about y-intercept and the rate of change, the m and the b. All right, so first of all, to begin with, the y-intercept of a function, or b, so highlight b if you have your highlighter, underline if you don't, all right, is known as the initial value. All right, it's the initial value of the function. All right, so really quickly, I'm going to look down here. With every single problem today and on your homework, it will say, write the function and interpret the rate of change and initial value. So your rate of change and initial value go along with your function, okay? And the initial value is your b. All right? You can find your initial value when your y-intercept is where x equals 0. Okay, so yesterday on a few of our graphs, we had graphs that told us where x equaled 0, and then we could find our y-intercepts really easily. Today, none of our graphs do that. Okay, so today we have to solve for b every single time. So you can find the initial value of a function as well as its rate of change by using tables, graphs, and words. Today, as we construct our functions, we are looking to create functions in y equals mx plus b form. Okay, the slope-intercept form, we're familiar with it. We talked about how functions can also be called equations, so we're essentially creating our equations. Where m is what? It's our rate of change. And our b is the, again, initial value. All right, so when we go to interpret these things, we're familiar with this equation form, so it should be easy to identify what our rate of change is and what our initial value is within the equation. Now, a few things that will help you. All right, initial value are oftentimes referred to as one-time, or in story problems, are one-time or monthly or yearly fees. All right, they are our beginning values. All right, so what we begin with. So when we interpret our initial value, we would say she began with, or it began with, or it started with. Okay, those are common ways to interpret. So we're going to take a look at example 1. And like I said, this is very much like what we did yesterday. We are going to be solving for m, solving for b, and writing an equation. So number 1 says, a shoe store offers free points when you sign up for their rewards card. Then, for each pair of shoes purchased, you earn an additional number of points. The graph shows the total points earned for several pairs of shoes. Find and interpret the rate of change in the initial value. So first of all, there are some phrases in here that identify what you might use for your initial value or your rate of change. So first, highlight. They offer free points when you sign up for their card. And then, for each pair of shoes purchased, you earn an additional number of points. All right, so this right here in our story problem already tells us what our initial value and our rate's going to be. All right, when you first sign up, this is the initial value. Okay, so when you sign up for this rewards card, which a lot of stores have things like this, just for signing up, they're going to give you a certain number of points. All right, how many of those points are, that's our job to figure out, but that's what the initial value is. You just get a lump sum of points. Then, after that, each pair of shoes has a certain number of points that you earn. So that is our rate of change. Those additional points you earn as you buy more shoes, that's the rate of change. Alright, so we need to use this graph to help us solve for those. So first of all, let's look at what ordered pairs we could use. We have the ordered pair 260. We have the ordered pair 490, 6 120, and 8 150. Alright, to solve for M, we're going to use, for all of our examples, that y minus y over x minus x, our slope formula. Now, you could technically use any two ordered pairs. To keep it like continuous and uniform, I'm always going to use just the bottom two ordered pairs. So 260 and 490. So y is 60 minus 90 over x, 2 minus 4. So 60 minus 90 is negative 30. 2 minus 4 is negative 2. When I simplify that, who can tell me what is negative 30 over a negative 2? What does that simplify to? 15. Very good. So we have solved one part of our function. We have our m. Now, to solve for b, we always start with our slope-intercept form. We have our m, and we could use any one of these four ordered pairs for our y and our x. Now, again, just to keep things uniform, I'm going to use the first one. Alright? So, my y is 60, my m is 15, my x is 2, and I'm going to use those three values to solve for b. Again, this is the repetitious part that we've been doing since chapter 3 that you really should have down by now. So 15 times 2 is how we simplify first, is 30 plus b. To get b by itself, I'm going to subtract 30 from both sides, leaving me with 30 equals b. Alright, the first part is let's put this together and write our function. So we want to write our function in y equals mx plus b form. So we want to write a slope-intercept equation. So y equals 15x plus 30. Now comes the new part. Now comes the part that's a little bit more difficult. Now we actually have to interpret and put this in context with the story problem. Alright, now, since this is the first one, I already highlighted and identified to help us. So, when it says interpret the rate of change in initial value, you could say, let's start with rate of change. 15 is the number of points for each pair of shoes you purchase. So, you could say 15 points per pair is the rate. Alright, so the rate of change is 15 points per pair. This 30 goes along with those free points at the beginning. So 30 points are given when you start or when you begin. Alright, so you start off with 30 right away. It doesn't matter if you buy a pair of shoes or not, but then after that they give you 30, or not 30, but 15 points for every new pair of shoes you buy. Alright, example 2 is a little bit more difficult because it doesn't give us as much helpful information in the story problem. Okay. Example 2 says, the graph shows the distance Jeffrey is from a water fountain after a certain amount of time. So this is how far Jeffrey is away from the water fountain. Find and interpret the rate of change and the initial value. Okay, now I just want to show you, if I were to continue this line, if I were to use my straight edge, notice here, it's really not going to go through 0, 0. So this is something I talked about earlier today. There's not going to be a b that equals 0 today. Every single time we will calculate the value. So again, let's start off by finding our m by taking y minus y over x minus x. Again, in order to do that, we need to identify these ordered pairs. So we have 3, 8. We have 4, 10. And we have 5, 12. All right, so let's start off by finding our slope or our rate by subtracting. I have 8 minus 10 over 3 minus 4. 8 minus 10 is negative 2, over 3 minus 4 is negative 1. So m equals 2. That's our rate. Now, we don't know yet how that applies to the story problem. All right? Like I said, they don't give us as much information as the previous problem did. Now let's solve for b. So again, start off, y equals mx plus b. I'm going to use the first ordered pair. What am I going to plug in for y? What am I going to plug in for y? Tyler? 8. What am I going to plug in for x? I'm sorry, not x, but m. Lorelai? 2. And what am I going to plug in for x? Ellie? 3. Very good. Now let's solve for b. Simplify. 2 times 3 is 6 plus b. I want b by itself, so I subtract 6. 8 minus 6 is 2 equals b. Alright, so now I have everything I need to write my function. So this part is the easy part, just writing your function. So y equals m, or 2x, plus b, or plus 2. This is now the more difficult part because, unlike example 1, it doesn't give us any information besides the fact that it is the distance Jeffrey is away from a water fountain. So does anybody want to try to interpret? Let's start with our initial value. Does anybody want to try to interpret what that means? So, who would like to interpret what the 2 stands for? Anybody? Okay, remember, B is always where we begin. So B, or this 2, is how far Jeffrey starts from the water fountain. So Jeffrey begins 2 feet from the water fountain. All right, when in doubt, just think about initial value means where you begin or where you start. Okay, if we're not talking about like a fee or a plan or a rate like that, just think it's the beginning value. Okay, so he begins 2 feet from the water fountain, and then he has this rate of feet per second. So from that, he walks at a speed of 2 feet per second. So that, the second part is just saying how quickly or what is the rate that he also walks away from the water fountain. All right, now, your got it problem on the next page is more like example 1. It talks more or gives you more context clues in the story problem. All right, so flipping to the back, I will start and talk through this, but then I'll have you solve Got It Problem A. Got It Problem A says, Music Inc. charges a yearly subscription fee plus a monthly fee. So each year they have a yearly fee, and then each month they charge a monthly fee. The total cost for a different number of months, including the yearly fee, is shown in the graph. Find and interpret the rate of change and initial value. So again, I'm just going to highlight the 2 ordered pairs that I will use when I go over my example. But I would like you to try to solve for M and B and interpret on your own. Okay, so here your rate is 3 when we solved using the 2 ordered pairs. Your B is 12, which gives you the function y equals 3x plus 12. Does anybody want to take a stab at what? Let's start with the 12. What do you think the 12 represents? Tristan? Very good. $12 is the yearly subscription fee. It gets charged one time. Okay, so that's your beginning fee. All right, which leaves the $3 as the monthly fee. All right, so now since we've seen a few examples, I'm going to start to move a little bit quicker through these, but our next set of examples go with tables. All right, so example 3 says, the table shows how much money Ava has saved. Assume the relationship between the 2 quantities is linear. Find and interpret the rate of change in the initial value. The only difference now is your ordered pairs are organized in a table instead of a graph. You still have a y minus y and an x minus x. All right, so you're still able to find your rate just like you did on a graph. So using any 2 ordered pairs from the table, y minus y is 110 minus 130 over x minus x, 3 minus 4. 110 minus 130 is negative 20. 3 minus 4 is negative 1, which simplifies to m equaling 20. Again, the B is the exact same process that we've been doing for the rest, but again, instead of organizing in a graph, it's organized in a table. So again, choose any of these 4 ordered pairs. I'm, like I did before, just going to use the first one. So y, or 110, equals m, or 20, times x, or 3, plus b. Now I simplified to solve for b. So 110 equals 20 times 3, or 60, plus b. To get b by itself, I subtract 60 from both sides, and I'm left with 50 equals b. All right, so we've accomplished half of the lesson, not lesson, but question. What is the function? Or write the function. Y equals 20x plus 50. Now, again, this problem doesn't give us much more information besides the fact that the table shows how much money she has saved. We know that her saving is measured in both money, but also measured by how long she saved. So first of all, who wants to guess what does 20 represent here? If we know that it's a balance in months, what would it be? Madison? Not the number of months she saved. Anybody else? Again, we're comparing money and months. Azarian? Huh? The money she saved what? Tristan? Not yearly. How did we measure time? Months. So the $20 is $20 per month. So if she's saving $20 per month, what does the 50 stand for? What does the 50 represent?
Yearly.
Not yearly, no. Think initial value is what you begin with. So she started with $50. So $50 to begin. All right, that's how much she had before she even started saving. All right, so we'll get through example 4, and then we'll start with got it problem B in lab. So example 4 says, a science center charges an initial membership fee. Notice that's really nice because it even uses the word initial in it. A science center charges an initial membership fee. The total cost of membership depends on the number of people on the membership as shown in the table. Assume the relationship between the two quantities is linear. Find and interpret the rate of change in initial value. So again, let's start off with solve for M. Now again, this is really nice. It tells us what the initial fee is. So then all we have to do is interpret what our rate is. So M is y minus y over x minus x. So if I use these two, 65 minus 80 over 2 minus 3 is negative 15 over negative 1 or 15. To solve for B, to solve for that initial membership fee, let's use this ordered pair and plug it in for y and x. So 65 equals 15 times 2 plus B. Simplify 15 times 2 or 30 plus B. Subtract 30 from both sides to solve that. 35 equals B. So it already has in the story problem that's an initial membership fee. So first of all, before I get ahead of myself, the function is y equals 15x plus 35. Do not skip that part on your homework tonight. All right? So to interpret, the beginning value is $35 initial membership fee. Now, as for the 15, it's going to be $15, but what is the rate? How do they charge after you pay that initial fee? Madison? Very good. $15 per person. So as you add people, they charge you $15. So when we get in lab, we will talk about got it problem B. For got it problem B, here are the rates and the initial value. Okay, so I've given you everything with the exception of the interpretation again. We'll talk about that together. All right, so for M, hopefully you got 10 hundredths or 1/10. For B, hopefully you got B. Not B, sorry, you got 10. So your equation is y equals 1/10 x time, or not, 1/10 x plus 10. So now let's interpret what these mean. All right. Does anybody want to take a guess at, it doesn't matter, either one, you can tell me what either one means. All right, and again, it's talking about a monthly cost of sending text messages. Tyler?
For every text, it's 10 cents.
All right, perfect. So the rate is 10 cents per text message. All right, that's how much they charge per text message. What does the 10 or the B represent? Madison? The monthly fee. Very good. So the $10 is a $10 monthly fee. That no matter how many text messages you send, all right, you're always going to pay $10. All right, so we've taken a look at graphs. We've taken a look at tables. The last ones are story problems. Now, these are a little bit more complex, and we have to interpret the story problem. But once we do the first two examples, I think you'll catch on really quickly. All right, so example 5 says, Joan has some photos in her photo album. Each week she plans to add 12 photos. All right, so I'm going to highlight that. Each week she plans to add 12 photos. Joan had 120 photos after 8 weeks. Assume the relationship is linear. Find and interpret the rate of change in initial value. Now, one thing that makes the story problems easier is that your rate of change is actually given to you in the story problem. Can anybody tell me what is the M here? What is the rate for her photos? Nathan? 12. 12. Very good. So M is 12. So we can even go straight to that interpretation and say she adds 12 photos per week. All right, so that's one nice thing about the story problems. The other part is we need to use this other or these other two numbers to come up with their ordered pair. All right, because in order to solve for B, we need an M, which we have, but we also need an ordered pair and an X and a Y. So this is where we have to come up with, well, which one is our X and which one is our Y? Well, the weeks determine how many photos she has. Okay? So we're kind of thinking of independent and dependent variables here. Her photos, which we said dependent was Y, her photos depend on how many weeks she is adding to her photo album. So the ordered pair that we would be using is 8, 120. Okay, and that's what makes these story problems a little bit different, is we have to figure out what our ordered pair is. Once we've done that, the process is still the same. So Y is 120 equals M, or 12, times X, or 8, plus B. I first simplify by multiplying, so 120 equals 96 plus B. To get B by itself, I subtract 96 from both sides, and B equals 24. So again, I have my M, and I have my B, so I can create my equation. Do not forget to write your equation on your homework. Now, we already interpreted her rate of change. Who would like to interpret her initial value, or what does the 24 represent? Lorelai? Not weeks, nope. Brody? How many photos she had before. So remember, initial value is that starting point, that beginning point. So she started with 24 photos. So before she even started to add anything, she already had the 24 in her photo album. All right. And then we'll do example 6, and you'll try Got It problem C on your own. example 6 is really, really similar to Got It Problem C, so it should be fairly simple for you. So, example 6 says, a zoo charges a rental fee plus $2 per hour for strollers. The total cost of 5 hours is $13. Assume the relationship is linear, find and interpret the rate of change in the initial value. So again, like before, the rate is given. Who can tell me what is the rate here? Hallie? 2. Which again, we can go right down here to interpret because it even says $2 per hour. So my rate is $2 per hour for strollers. That leaves us solving for our B, which is going to end up being this rental fee. Okay, so what the zoo does is they charge you a rental fee, and then you pay per hour for using the stroller. So, again, we have to figure out what's our X and what's our Y. So we have 5 and 13 we need to determine. Now, if our Y is our dependent variable, which of these can we not know without the other information? Is it the hours or the cost? Which can we not figure out without knowing the other information? Jack? The cost. Okay, so our Y is cost, our X is hours. And like I said, Got It Problem C is super similar to this. It also has a fee and a cost per hour. Alright, so I use Y equals mx plus b, where Y is 13, m is 2, and x is 5 to solve for b. Simplify by multiplying is 10 plus b equals 13. Subtract 10 from each side, and I have 3 equals b. I put my m and my b together to write my function. So y equals 2x plus 3. What does 3 represent in this equation? What does 3 represent, Nathan? The rental fee. Perfect. So it's a $3 rental fee. All right, so looking at the back, Got It Problem C. Just like previously, you're going to solve this one on your own. But once we read through it, you'll notice it's super similar to exactly what we just did. A historic museum charges a rental fee. There we have another rental fee. Plus $2 per hour for an audio tour guide. The total cost for 4 hours is $12. Find and interpret the rate of change and the initial value. All right, so do the same thing we did for the previous 2 problems. For this one, because it was so similar to the other one, here is the answer. All right, the rate of change, again, was given to you in the story problem. It's $2 per hour. All right, it was the same rate as the last one, but instead, this time you're not renting a stroller, you're renting audio equipment. All right, 4 hours for $12. Your cost depends on hours. So here's our ordered pair. And when we solve, we get B is 4. So your equation is y equals 2x plus 4, where 2 is the $2 per hour, and 4 is the rental fee. All right, so on your homework, you will have 2 of each kind. All right, you will have 2 tables, 2 graphs, and 2 story problems.